Now let's look at the recurrence formula for the Bessel function. Recurrence formula. We will see 6 recurrence formula for the Bessel function. The first one is x jn prime of x, that is equal to n jn of x minus x jn plus 1 of x. So this is the first one that we see, the recurrence formula 1. Jn prime, that is the first order derivative of jn of x, d by dx of jnx, that is jn prime. Okay, so we know jn is this, jn of x is given by this. Here we see x here, x by 2 over n plus 2r. So when I take the first order derivative, we differentiate with respect to x, we get jn prime of x as equal to jn prime of x is equal to sigma r equal to 0 to infinity, this minus 1 to the power r over r factorial gamma n plus r plus 1. And as you differentiate this, you get x n plus 2r here, and the power here will be n plus 2r minus 1. And then as you differentiate x by 2, you will be getting half here. Okay. So this is our jn prime of x. So, okay. Now if I take x jn prime of x, if I am taking x jn prime of x, then you will be getting this. Okay, sigma r equals 0 to infinity minus 1 to the power r or factorial gamma n plus r plus 1 n plus 2r x by 2 to the power n plus 2r. Okay, you will be getting this. Now we are separately writing the term corresponding to n and 2r. We are expanding this, so n is coming here and 2r comes here, and here this 2r, as it combines with this r factorial in the denominator, you will get r minus 1 factorial in the denominator. Okay, so we have this r minus 1 factorial here and an x by 2 here. So this is n sigma r equal to 0 to infinity, and this is basically the Bessel function jn of x. This is jn of x. But here we look at this, we see an r minus 1 here and this n plus 2r minus 1 here. Power of x by 2 is n plus 2r minus 1. So we make a change. We put r minus 1 equal to s. So a new summation variable you are taking. Here we are using this only in this second one. This one is in the form of jn of x. Okay, we make change. We put r minus 1 equal to s only here. So r minus 1, that is equal to s. So when r equal to 1, okay. So when r equal to 1, s is equal to 0. When r equal to infinity, s is equal to infinity. Okay. So we have this sigma r equal to 1 to infinity here. Then that r equal to 1 to infinity, that becomes s equal to 0 to infinity if you make this substitution. So we have this s equal to 0 to infinity, x here. X, we are writing this as n plus 2r, n plus x by 2 to the power n plus 2r minus 1. So we will get an x by 2 here. Okay, that is written here. You will be getting an x by 2. That x comes here and this 2 that will cancel with these 2. Okay, that's how you get an x here. Okay, so here in terms of s, you will have this. Okay, minus 1 to the power s plus 1 over s factorial gamma n plus 1 plus s plus 1. Here you have n plus 1 plus 2s. Okay, here n plus 1 plus s plus 1. Here minus 1 to the power s plus 1, this minus as it goes outside. Have this. So this is minus x j n plus 1 of x, minus x j n plus 1 of x. So we get this x j n prime of x, okay, x j n prime of x, that is equal to n j n of x minus x j n plus 1 of x. Okay, so this is our first recurrence relation. Then formula 2, the second recurrence relation. Second relation is again formula for x j n prime of x. Okay, x j n prime of x, the formula. So as we did before, the last formula, we are taking j n of x, this is j n of x. We are differentiating, and as in the previous case, we will be getting n plus 2r by half here. Okay, n plus 2r by half here. Then we are writing this n plus 2r as 2n plus 2r minus n. We are writing this as 2n plus 2r minus 1 minus n. So we have x j n prime of x equal to r equal to 0 to infinity minus 1 to the power r, x by 2 to the power n plus 2r. Okay, r factorial over gamma n plus r plus 1. So here we have 2 times n plus r, n plus r. Here 2n plus 2r, we are taking 2s common factor. And here we have x by 2 to the power n plus 2r. Here this term is basically our j n of x. Okay, this is simply j n of x. So one can write this as minus n j n of x. And this one, here we have this n plus r here. And if I take an x by 2 from this is originally x by 2 to the power n plus 2r. If I take an x by 2 from it, this will become x by 2 to the power n plus 2r minus 1. And I have this x by 2 here. Okay. So this 2 will get cancelled. I will get x here. And see, I can write this as n minus 1 plus 2r, just a rearrangement, n minus 1 plus 2r. Here n plus r, gamma n plus r. This is gamma n minus 1 plus r plus 1. Okay. So we have this x j n minus 1 of x here, j n minus 1 of x here, and here we have minus n j n x. So we have the second formula. So just by differentiating and making some rearrangements, you arrive at this formula. We have the second formula again for x j n prime of x. Okay. Now if I add equation 1 and 2, this is equation 1 and this is equation 2. If I add equation 1 and 2, I get what? This 2jn prime of x equal to jn minus 1 minus jn plus 1 of x. So this is quite simple. You just add equation 1 and 2. So on the left hand side you will get 2x jn prime of x, and on the right hand side you will get x jn minus 1x minus x jn plus 1 x. X will get cancelled, and you have this 2jn prime of x equal to jn minus 1 of x minus jn plus 1 of x. So this is the third recurrence formula. Then the fourth one, that also is quite simple. What you do now is subtract the second recurrence formula from the first recurrence formula. So on the left hand side you have 0 because for equation 1 and 2 the left hand side are equal, and on the right hand side you have this 2njn of x, you will get 2njn of x, then minus xjn plus 1 of x minus xjn minus 1 of x. So you have 2njn of x is equal to xjn plus 1 of x plus jn minus 1 of x. Okay, so this is formula 4. Okay, the fourth recurrence formula. So first two recurrence formula you have to differentiate and you have to make some rearrangements. Third and fourth recurrence formula can be obtained from first and second recurrence formula. The fifth one, d by dx of x raised to njn of x, that is equal to x raised to njn minus 1 of x. How do we get that? Take the second recurrence formula. What is it? Second one. The formula second one is this xjn prime of x is equal to xjn minus 1 of x minus njn of x. Okay, so we are taking that, and then what we do, we multiply both sides by x to the power n minus 1. We are multiplying by x to the power n minus 1. So you have x raised to n here, and here as you multiply you will get x raised to n, and here you will get minus n to the minus n x to the power n minus 1 jn of x. Okay, now what we do, we are taking this as shown here, we are taking minus n x jn minus n x to the power n minus 1 jn of x to this side. So we have x to the power n jn prime of x plus n x to the power n minus jn of x equal to x raised to the power jn minus 1 of x. So this is d by dx of x to the power n jn of x, d by dx of x to the power jn of x. Okay, this is clearly if you apply the product rule. Okay, this is x to the power n jn prime of x plus n x to the power n minus 1 jn of x. So you will be getting x to the power n jn minus 1 of x. Okay, so you have the, what is it, the formula 5, then comes the formula 6. You start from the for obtaining this, start from the first recurrence formula. This is the first recurrence formula. We multiply both sides by x to the power minus n minus 1. So you get x to the power minus n here. You are multiplying with x to the power minus n minus 1. X to the power minus n minus 1. You are multiplying. So on the left hand side you have x to the power minus n jn prime of x, and here you have n x to the power minus n minus 1 jn x. Then you have the x to the power minus n jn plus 1. Okay. Okay. So if I take this term, if it is taken to this side, I'm taking to this side, I have this x to the power minus n jn prime of x minus n x to the power minus n minus jn minus x to the power minus n jn plus 1. So you get this d by dx of x to the power minus n jn of x. This is jn of x. That is equal to minus x to the power minus n jn plus 1. Okay. Then if I put n equal to, so we get the sixth recurrence formula. Then if I put n equal to 0 here, suppose I put n equal to 0 here, this term will become 1, then we have the j0 prime of x, that is equal to minus j1. Okay, and minus j1 we know that is equal to j minus 1, the first property of the Bessel function that we have seen. Okay, minus j1 is j minus 1 because j minus 1 is minus 1 minus 1 j minus 1. Okay, if j what we have seen in the first property is j minus n is equal to minus 1 to the power n jn of x, isn't it? So j minus 1 will be minus 1 to the power minus 1 j1 of x. Okay, minus 1 to the power minus 1, that is minus. Okay, so j minus 1 is equal to minus j1 of x. J minus 1 is minus j1 of x. So here instead of minus j1 I can write j minus 1. Okay, so j0 prime of x, that is equal to j minus 1. That's an interesting result. So we have seen 6 recurrence formula for the Bessel